This is Saxon Advanced Math, lesson 90.A, and we're dealing with double angle identities. Double angle would be two of the same thing, right? Double. The first thing we're going to do is start with a little bit of review. So bear with me. These are our 6 normal identities that we should be memorizing at this point. I'm telling you, take the time to memorize these. It gets a whole lot easier if you have them memorized than it is trying to look back every single time. Homework and tests take forever if you're trying to look these things up. So here's my 4 that we've already used. Of course, these were the 2 that were review on that other lesson. But we're going to move into a double angle. So let's say the example 90.1. Develop the identity for sine of 2a and the cosine of 2a. So let's just take the first one, 90.1a. And first of all, we're going to realize that this sine of a plus b, all I'm going to do is rewrite this line right here. So all we've done is use that. Now, if I wanted to say 2 of the same thing, I'm really just adding, instead of saying a plus b, I'm saying a plus a, right? So if the a equals b, I could really say it's the sine of a plus a. Well, the sine of a plus a could be rewritten and say this b becomes an a, and this b becomes an a, because they're the same thing. That's what 2 of something means. So when I do this, I get sine of 2a equals sine a, cosine a, sine a. Well, if I change the order around, I'd have sine a, cosine a, sine a, cosine a. Well, if I had the 2 things being added together, I can very easily say, okay, well, the sine of 2a is 2 times the sine of a times the cosine of a. Very easy. And we should be able to not necessarily memorize that, but define that very quickly and easily. Now, with the next one, for b, they asked us develop the identity for the cosine of 2a. There's actually 3 separate answers. I didn't write the third answer down here. I wrote the answer, but not the word answer 3. But let's go ahead and go through this. So we're going to start the same way, cosine of a plus b, right? And we're going to say a equals b, and we're going to use the cosine of a plus b and substitute that in. The difference, though, is I get cosine a, sine a, sine a. Well, if I have 2 things being multiplied together, that's by definition squaring them if they're the same thing. And so I end up with this right here for answer 1. The cosine of 2a is the same thing as a cosine squared a minus sine squared a. Well, that's easy enough. That's answer 1. However, if we go back to what we know about our identities and we realize, here we go, with sine squared plus cosine squared equals 1, of theta, then I can very easily come back and say, well, can I redefine this as saying the cosine of a is cosine squared a is 1 minus the sine squared a, right? By just moving that to the other side. And if I move the cosine to the other side, I get sine squared a equals 1 minus the cosine squared a. So what if we use that and we adapt this and we say, what if the cosine of 2a was, well, we plug that in. And we say, oh, the cosine squared is 1 minus the sine squared. So I plug that in right here and get 1 minus sine squared a minus sine squared a. All I've done is substitute in right off of this, because I know that cosine squared a is in this problem, and I know what cosine squared a is. It's 1 minus the sine squared a. So I plugged this, I substituted this into this equation, giving me this one. That's all I've done here. So don't let that get confusing. If you need to stop and think about that a minute, that's okay. Pause the video and come right back. 1 minus the sine squared a minus sine squared a. Well, I don't need the parentheses anymore. And I say negative sine squared a minus sine squared a is a negative 2 sine squared a. And there's my second answer. Cosine of 2a is 1 minus 2 sine squared a. All right. Well, let's go ahead and do that same thing, except we'll use the other one. So instead of substituting for the cosine, let's substitute for the sine. So we're going to take this one here and say 1 minus the cosine and plug it in. Now, parentheses become very important. The book has it in bold for a reason. Be careful of negatives, I think is what the book says. Because I have a cosine squared a, right? That was from my original answer. Minus the sine squared a, which I plugged in as being 1 minus the cosine squared a, but I have a negative out here in the front, and I have to use my parentheses or else I will get an incorrect answer. I end up canceling it out and saying the cosine of 2a is 1, and that doesn't work. So I say, or a negative 1. I put negative 1, so a negative 1 is negative 1, and a negative becomes a positive. Now I can say cosine squared a plus cosine squared a is 2 cosine squared a minus 1. And that's my third answer, or my third identity. And I have, as much consternation as pain as this causes people looking at it, saying, why? Why do we have to go through this? A lot of books, they tell you to memorize these without ever explaining them. I hate that. This curriculum at least goes through and says, here are the ones that you have to memorize. You can always come out and derive these. Okay? Which is, if you know how to derive them, you can get to them very easily. You don't have to fill your mind with, well, what are the three different identities for the cosine of 2a, or the double angle identities, and you memorize all three of these in addition to these, and the double angle identity for the sine, and memorize that as well. The book is not asking you to do that, but it is asking you to go through and know how to define them, how to work them back out, and get back to your different identities using what we already did memorize.